Hi, I'm Diana ENG, and today on Make we're going to be looking at how electromagnetic waves are transmitted by antennas. We're going to be playing with this light bulb receiver and also with this YAGI antenna that I use to communicate with satellites. Radio receivers like this one convert incoming radio waves into sound you can hear. But this is a very simple radio receiver that converts radio waves into light. It's just a light bulb from a flashlight hooked up to two pieces of wire. The wires create what is known as a dipole antenna. A dipole antenna captures radio waves and converts them into alternating current, like this. In this device, that current flows through the bulb, causing it to light up. My light bulb receiver isn't very sensitive, so to give it something strong enough to receive, I set up my amateur radio transmitter and connected it to an antenna that I normally use to send signals to satellites. Right now my transmitting antenna is set up as a dipole, just like the receiving antenna. And when I transmit a signal, the transmitter actually forces electric current up and down in this transmitting antenna over here. And so because of the magic of radio, the transmitting antenna will induce a current in the receiving antenna, and so it'll force the electric current up and down in this antenna as well, and through the light bulb, lighting it up. So let's see, I'll just push this button over here to transmit a signal, and then we can see the radio waves being sent to the light bulb over here. And as I move the light bulb closer, you can see the light bulb gets brighter, and there's a higher signal strength, and then the signal strength kind of drops off over here as the light bulb dims. Because I'm transmitting with very low power, and because this light bulb isn't very sensitive, we can only see the radio waves that are being transmitted close to the antenna. But the physics are actually exactly the same for waves that are being sent thousands of miles around the world or millions of miles into outer space. Right now, this dipole antenna is sending radio waves in 360 degrees horizontal to the antenna. So you can see we're moving the light bulb all around and it's sending out a signal. Now, if we want to, we can send a stronger signal to one location and essentially focus the radio waves to create a directional antenna that sends a stronger signal. First, I will add what is known as a reflector, and it's basically a piece of wire that's cut to a certain length and placed a certain distance away from the main part of the antenna. So I'll just slide it in. The reflector back here basically acts like a giant mirror. So the energy sent by the transmitting antenna bounces off the reflector towards the front of the antenna. So all the electromagnetic waves are really focused towards the front of the antenna. We can actually see this with our receiving light bulb. As I move the light bulb from the front of the antenna in the same 360 degree horizontal pattern as before, you can see that the light bulb gets dimmer towards the back and brighter towards the front. Next, I'm going to add what is called a director element, and its length and placement are basically determined according to some formulas. You can look these up online, and I'll just slide it in right over here. The director acts like a lens, and it basically focuses the energy from the transmitting antenna, or the driven element, towards the front of the antenna. So we can take a look at it with our receiving light bulb over here. The signal is actually going up to the front of the antenna, so signal strength has greatly increased. And when we take a look at it back here, let's see, so you can still see signal up here, but when you look at it back here, towards the driven element, the light bulb isn't lighting up at all. You can keep adding directors to the antenna, and the beam becomes narrower and more intense. This type of antenna is called a YAGI antenna, and with this particular antenna, I can communicate with satellites using a 5-watt radio. Now, if you were to add more elements to the antenna and have a more powerful radio, you could communicate farther. For example, you might be able to bounce signals off of the moon. So let's use our receiving light bulb and take a look at the signal strength of this YAGI antenna. Let's see, so if we look out here, we can see that the light bulb is lighting up. So the signal strength is very good out here, and it's actually quite far from the driven element that's in the center. And you can see here's the driven element, and if we go behind, there's no signal. So the directional antenna is really working.